Good morning to all. It's really morning, I know. And thank you, Jérôme, for the introduction. Maybe I can call the panel to step in because we'll try to maintain timings. And so please go there. Just for the very short introduction, I would like to make to this roundtable one of the defense session. We'll have, as explained, to understand, decide, and act. And this has been the way to solve problems for centuries. Nothing new. The point is that we do today, we are sharing. And sharing information has tremendously increased these last decades with digital transformation. And as we've seen yesterday and today, and I think in the day-to-day life of now artificial intelligence. We are talking about defense context. And so what does it mean? Concretely, it means that we still try to solve problems. The point being that those problems have been created by an adversary. And the key element will be to be able to deal with the problems faster than the adversary is creating them. And it's all about getting a success for us will be a failure for him and the other way around. So measuring this will be critical. We are talking about aerospace. Why is it kind of specific? It's because things are moving fast in this world. Objects are moving all the time. And so getting this sharing of information is even more complicated than when you are infrastructure capabilities. Then what about AI applications? We've seen many of those in the aerospace world. All this will remain and we'll have to deal with those to be able to concretely measure what it will require. We've seen it require a lot of resources. It requires human resources, it requires financial resources, and it requires data resources, plus energy, all what's going with that. And so the question will address to the panel, because of course 60 minutes is not enough to address all the AI implications in defense world and aerospace and defense world. Specific question is, okay, how do you expect the added value of AI that we've seen there, AI applications, AI augmentation, to be measured? How do you expect to have a clear view of what will be required, and not forgetting that mistakes in the defense world mean deadly mistakes, mean casualties, mean dramatic effects. So we have a very high level of exigence that you find in the safety issue that we alluded yesterday to, but now also in the fact that you cannot afford mistakes that will prove to be really devastating. So for this, I'm very happy to welcome the panel, plus one Ed who is online with us today, coming from and talking from United Kingdom. And so to answer the question, first on the user's perspective, what do you expect? I will leave the floor to General Moritz, have been well introduced, and we've been knowing each other for quite a while. Currently the head of the operational head of the French FCAS system. And what kind of formation do you expect to make those choices? Will be what would has as a first question. We will do that in 30 minutes, so it's 5 minutes for each of you. And we'll be there with Jérôme to be the timekeeper of that. And so that we leave time to have a debate because there is no, I guess, simple answer. Thank you.
Fair one? Yeah, okay. Thank you, Bruno. Yeah, I think AI will definitely be present in so many areas, functions, professions, for the purpose of simplification, for the processing of billions and billions of data to go faster, to relieve human of non-rewarding tasks. Likewise, in the defense area, I think AI will assist, and especially the armed forces, in planning tomorrow for force readiness, for logistics, for administration and support, and of course, of all kind, to conducting all kind of operation for the protection of the French on our territory, but also for the preservation of our interest in all around the world. The main idea, and I don't want to depict a dark vision about AI, but AI is not a goal. AI is not a capacity in itself. The development of military capabilities that we will need to carry out the operational mission just mentioned a moment ago will follow rather invariant principles, particularly with regards to the characterization of the military requirement. That means, when I'm speaking about military requirements, as invariant principle, the knowledge of the threats. We spoke about threats just a few minutes ago. The second point is the clearest possible identification of our security interests and a set of representative scenarios to build our capabilities. As well, capabilities processes obviously cannot do without a sequence like starting with conceptual studies, technological maturation, demonstration before approaching the development and the production phase. This is the case for the new generation weapon system I just depicted before. AI will not escape these processes for which it will be necessary to gain in agility in the future because our competitors are going faster and faster without the constraints we have in our European way of thinking. So having said that, what do I expect from AI by focusing a bit more on future operation, especially future air operation, which after all concerns the French Air and Space Force and its future. So it has, I just depict here 4 points. And you know all these points, but it's important to remind it. First, it has to reduce tedious and time-consuming tasks, prone to human error as well. Second, it has to erase human limitation. For this, I will give you an example to illustrate that. The third point is AI should propose option and decision whose development cannot be carried out by humans or classic algorithm. The fourth point is produce measurable effects in terms of efficiency and the reduction of time loop. Produce measurable effects. That is, I realize this with the fact that AI is not a capability in itself. Okay, so let's not take AI because we must have AI. Let's take AI because we are sure that AI brings something more. If it doesn't, no way. I would like to just to illustrate this with the new generation weapon fighter, the fighter in the new generation in the NGWS. In a disruptive approach, we aim, as I told it before, we aim at a revolution inside the cockpit. We must therefore completely rethink the man-machine teaming and man-machine interface in all its dimensions. I see 4 dimensions for that. There is a, how can I say, an intellectual dimension, and for that AI assistance and rapid calculation are central. We want more decision proposal rather than machine management. A kind example. For example, instead of displaying red lights in the event of an engine failure, which is ultimately an unnecessary cognitive burden for the pilot when it's not immediate danger, I would prefer to present a well-constructed, reassuring with the sail decision of the impact of such failure on the mission when the time comes, when it's needed to present it to the pilot. This is something a bit disruptive because we are, as fighter pilot, we aim to see in the cockpit the engine, the failures. No, tomorrow we sweep those failures, we switch these failures, and the AI is there to just present a solution, not a problem. The second dimension is the psychological one. We have to guarantee the pilot a confidence in AI tool, for example, by a formal certification process. The third one is an emotional dimension, and for that training will be essential and must be adapted to the system and to the evolution of the air combat. The fourth one is physics. Yes, you know, it's a common place to say that the technology is limitless, which is not the case for humans. It's therefore a question of supporting them to guarantee their place as an essential decision-making actors. So these expectations obviously raise many challenges and many difficulties. Some technological one, and Philippe spoke about it just a few minutes ago. There is a question of frugality and embedding. It's so easy to do AI at the ground because you have time, you have place, sorry, to put your data storage and your calculation storage. In the aircraft, you have no place. There is a question of certification, a question of trust, and a question of security. And hopefully we will find some answers this morning, once again, to all this issue. Am I in the timing, Bruno?
Almost.
Thank you.
Thank you. And so what I just take out of the importance of being able to measure the gain in time. The faster, the better. So now I will turn at range, at distance with the Ed. Are you there? Edward?
I am, yeah. Morning, everyone.
Okay, so great. Group Captain Edward Whitechurch, you were dealing for the Royal Air Force capability, well, you are dealing for the Royal Air Force Air Capability Strategic Command and Control. You have a fighter jet staff position experience in air operations. And so very concretely, to mirror the expectations fielded by General Kofi, how do you expect C2 command and control being affected and improved, obviously, by AI? And how would you assess this effectiveness, which is a key element? Floor is yours. Thank you.
Perfect. Thank you very much. And yeah, morning, everyone. Sorry I couldn't be there in person. So thinking about command and control and the application of artificial intelligence, I think the key starting point is in its current state, you know, it's not ready to have AI applied to it. There's a lot of problems to solve, and a lot of those are fully aligned with what we've already heard from the introductory remarks so far this morning. So if we sort of look at the problem with command and control first, essentially, and this is, you know, to a greater or lesser extent, I think common to most militaries, and it's certainly not unique to the air domain. But essentially, we are tied to the headquarters and the buildings and the tactical infrastructure that we have to operate, and within that, we're then tied to the multiple numbers of IT systems, often which are entirely different between what you operate with when you're at home and, you know, an entirely new set of IT when you're deployed. All of that has essentially driven our doctrine because we are constrained by those limitations and therefore we operate within them, and that causes problems and doesn't make it easy to get access to the data you need and think about where you would want to apply artificial intelligence. So kind of thinking about the future of command and control, we need to break as many of those constraints as possible. So a big part of that is the shift to a cloud-based approach to command and control. So delivering a combat cloud that everyone can access, contribute to, and benefit from. And that suddenly opens up huge freedoms. So the things that are provided to deliver command and control stop being a constraint and become a freedom. So your classical doctrine of centralized commands and decentralized execution, well, you don't necessarily have to follow that. So based on the problem you're faced with, almost on a daily, hourly basis, you will be able to decide the level of centralization that's appropriate and how much decentralization. And that's really key, because that buys you agility, it buys you resilience. The shift to a combat cloud, moving on to my second point, suddenly allows you to access all the data that you're going to need to successfully harness artificial intelligence. We've already touched on data. I think it'll come up again, so I won't dwell on that. But ultimately, your data has to be orchestrated, and some of that is easy, some of it's much harder. But ultimately, you want it in the right place at the right time, and then you can start to apply artificial intelligence to it. If you get all of that right, then you should be in a much better position to make sense, to understand the situation and the problem you're faced with. And at that point, you can start to layer in elements of machine assistance. And some of that will be artificial intelligence to help the humans. And there are many quick wins. So a lot of that data preparation, a lot of the first order analysis, that is absolutely perfect for machines to kind of take that job away from humans, leaving the humans to move from being in the loop to sat on the loop, being presented that information in hopefully a much clearer, much more detailed fashion, and letting them make the decisions. And that goes on to my last point, which is about making. If you're going to make better decisions, well, hopefully everything I've spoken about will enable that. But you also want to make better actions, and you can't think about those in isolation. So as well as applying artificial intelligence to decision making, and also still applying artificial intelligence to how you deliver operations, you need to link those two. And a big part of that is making your commander's intent and all the things that our current human deliverers of command and control do machine readable, so that you can apply artificial intelligence to them. So we've been doing some prototyping within the Royal Air Force focused around planning of air operations. So the air tasking order generation, if you're familiar with that. And that is essentially about how you can have AI involved from the outset, along with classical algorithms and just hard maths. It's not all about AI, as we've already heard, but there's absolutely a role for it to play. So rather than spending days with teams of humans planning operations through set processes, how can you condense the start of that down to something that is machine readable, and then let AI generate you multiple courses of action in seconds, not days, then bring the humans back in to assess those, and then ultimately have an equivalent set of AI that is monitoring the delivery of operations to understand when you've diverted from the plan much quicker than a human would, offer you the other options that are already within that plan, or if it's a total change because of the threat situation or things that have been out of your control, you go back into the planning phase and very quickly generate new courses of actions, that link between decisions and actions and that constant interplay. In terms of assessing the effectiveness of that, well, I think a lot of it, you shouldn't, as we've already heard about, think about AI as different to any other technology that's there to assist humans. So the current ways of assessing should be fit for purpose. You'll just be maybe assessing a machine rather than a human. Some of it will be easier to assess. How quickly can you plan? How quickly can you spot errors in your execution of air operations? How quickly can you fix them? I think there's also a risk that we try and over-assess, because ultimately, if you get this right, your artificial intelligence that you're using will outperform a human that's having a bad day, every day of the week. And we, in a lot of these cases, don't have the metrics and the ability to assess when humans are having bad days and good days. So we shouldn't over-assess, AI if we haven't got an equivalence in the sort of human cognitive domain as well.
Okay.
That is it from me.
Thank you, Ed, and a lot of insights in what key point of C2 is, and linking decision to actions is something that, as you mentioned on the slide, prototyping should be a way to answer whether it's useful or not, or at least worth the investment. So that was back now to our Paris insight with Christophe, Alix. You have been involved for a long time in R&T in autonomous systems, and now designing collaborative combat architecture. How do you see AI implemented in this designing and operating data systems aerospace? For which expected advantage? Again, 5 minutes to answer this question. Easy?
Yes, thank you, Bruno. It will be difficult in 5 minutes to get rid of all the questions behind that. First, a lot of things have already been said around AI and what we can do with AI. Yesterday, but today also about the use for AI for AWS or FCAS more generally. I would like to come back a little bit on the main goals for collaborative combat. Because I'm an architect, so I would like to understand what is the essence of collaborative combat. So I try to extract a few things that I think are key. And I found 4 main things, ranging from data coverage. First thing is to get the maximum of all available sources. So it's maybe a part that we all have to think about. And then use AI the best we can for such purpose. Second part is to automate everything that can be, so meaning everything that we know should be automated, and simply for the sake of giving time to end users and operators to solve the real problems, the new ones. So that's the second part. The third part is, of course, to solve problems, you have to make decisions. So it's about assisting or giving elements to make the better decisions as possible. And the last part, the fourth one, which is probably the most difficult, is to keep all options open as late as possible, meaning that if you want to be resilient and efficient, you have to take the decision at the right time and involve in the effects, in the action, all the assets and resources you have at that time. And it's a way to get the benefit from having so all the platforms we were discussing before, for example, in NGWS. So I will come back a little bit on these 4 points with bringing all the 3 third all together in an understanding of what is an information processing chain. And if we go from data collecting, so here the goal is to, of course, open to any available data, being ISR, for example, but also open sources, information, and here we would get benefit from AI to structure with NLP, for example, to structure information, and then it's about making sense from this data. So it's a full process, which implies, of course, something that we have not talked so much yet, which is about knowledge. So we have seen yesterday the different types of AI, so database or rule-based. And here we go really to understanding what is the domain and to represent the knowledge of the domain. And the goal for that is very simple, is to transform this information coming in into information that makes sense for the domain, for the operations, that makes sense, of course, for all the partners, human, but also machines, and to transform that into an understanding that will raise the right decision. Okay. Of course, and then the last part in the information processing chain is that decision making. And the goal for it is quite simple, is to make the right decision at the right time, at speed, at relevance, and of course, based on the latest information available. So a continuous operating mode. So that's one part, but the second part of the problem is the fact that we want to do that in a context where these chains, these collaboration loops, are not concentrated only on one place with one user making decision, but are distributed over different platforms in different places with a set of interactions between partners. And this is exactly the essence of collaboration, is to share a goal and do our best optimization, orchestration, whatever, do our best to make the best decision in this collaboration loop. And when it comes to distributed systems, this is more or less a nightmare. Because of course we have here to converge in terms of connectivity. The platforms are not at the same place and they are moving most of the time. So connectivity and also everything that it would take to connect this platform and organize all the resources and the distribution of these resources towards these collaboration loops. So a large set of problems there, which comes from first identification of these collaboration loops. This is not done yet, I think, globally. We are still lacking a global understanding and sharing of that, and then understand how we will express these collaboration loops with the good quality of service for each of them, and then be able to derive that on the so-called combat cloud for all of the layers, down to or to, it depends the way you want it, to the communication.
Thank you, Christophe, and congratulations for being the one to respect the 5 minutes. Sorry for that, but we try to keep on time and give everyone a chance to speak. So Pooja now. Pooja, you currently serve as the Fasttrack lead for AI for Airbus Group. Before taking on this position, been a head-on developer on machine learning and AI algorithms. So how do you see AI implemented throughout Airbus defense and space? Don't forget space, which also have defense aspects. For each concrete and measurable benefits, do you think it's possible?
Yeah,
thank you.
Sure. Thanks a lot, Bruno, for the question. So first of all, very happy to be here and sharing my ideas and discussing among the industry best today on the stage. But then I come quickly to who we are, what we do, and then your main question about value assessment of what we do. So firstly, we are an industry player today, and we are delivering and developing solutions when there is a customer request, especially in the defense domain. So our customers ask for a feature to be integrated on the product or provide a service to them in order to maintain the fleet they have, and we develop it as an answer to that. So that's what we do. And then, then what is AI for us? So we talked a lot about the what AI is and what it means in the defense world or in the civil world yesterday, for instance. And we sort of see it as an embodiment of something. And in Airbus, we see it more as a piece of software that's sitting that's not sitting anywhere. That's basically a part of your system. It's pushing you some information, maybe the same information that you already see today, but at a better quality or a better robustness. And then it's letting you or supporting you or assisting you in performing some tasks or taking some decisions. So therefore, if you think of the defense world and think of the OODA loop that we have here, in defense and space, we have topics we are running because of research and development interest or because our customers have asked for it. Across this loop, observe, orient, decide, act, we have topics and projects running on all of this, the full value chain. So we have situational awareness topics which are of importance to us. I can give you some examples. For instance, we have a product called as Massive Intelligence, which we sell to our customers, which is capable of collecting lots of open source intelligence and performing and providing insights out of this data. So this is one great example. From our space domain, we have a platform called as One Atlas, which is basically a data lake where we can collect the images, satellite imagery coming from the Earth observation satellites that we operate. And we have several digital services that we offer in that portfolio. For instance, first of all, imagery is of great importance. You can use the imagery that is available for many downstream applications, even in the military domain. So that's already a product. So data here is the product that we are selling. Second, the services that we offer on top of it, which are around analyzing what is the content of your image, and then sometimes even the resolution improvement or the image enhancement that these features are offering. And then if we come to so these were a bit of the services world, right? So if we come to the product world, we do have several topics which are in our R&D pipeline, for instance, and some of them which are also out there. If I talk of one of the topic that's already out there, you might have seen the press announcement around air-to-air refueling, which is a tactical mission assistance feature that we developed. A330 MRTT is one of our platforms, which is the first certified tanker capable of performing this refueling operation, which is an extremely important tactical assistance, very much physical, that you can offer during the mission or the combat scenarios, for instance. This is one example. I have 2 more minutes. Thanks. And then if I talk about what we have in our R&D pipeline, there are a number of topics around products that we are investigating. It will be an assistance to the crew, to the pilot. It will not have an embodied form. It will be a software which will push more information with more confidence, which can be used for decision making. Therefore, the planning and scheduling algorithms are also on the horizon, like mission planning systems, execution system, given a number of assets and then a number of threats and the terrain information. How do you plan your trajectory? This is also something that we are looking at. Then coming to your value assessment question, it's extremely important because we are an industry, we sell, and then what we sell gets into our P&L at the end of the day. Therefore, the assessment of value is extremely important for us. And it's different when it's a service that we are selling. There are sophisticated service models that we are following, which will see that there is some value generated in terms of the annual EBIT return. Then we talk about the products. It's more cumbersome because you're not really building an AI product and selling, but you're building a product and you are integrating AI somewhere in the loop. And then tracking how much have you spent in order to develop this AI feature and how much are you getting back because of this. It's a very advanced financial concept, and we are also trying to track it internally, and we see that the industry is also going in this direction. So we are waiting for also our partners and collaborators to give us some ideas there. But obviously in the military domain, it's all about bringing the time advantage, reactivity, and the mission success rate. So this is the main philosophical value that these AI concepts are bringing to the table. Beyond that, we obviously have the financial monetary value that we need to track and trace.
Okay, thank you. Very clear. And so we've seen that assessing the value is just something more than assessing the price, even if it's part of it and of course of business models. So keeping on after having seen the need, the command and control, the circulation of data, the platforms with Airbus, now with Dassault. Stéphane, you hold a PhD in computer science for artificial intelligence, long experience in human-machine teaming in the Dassault company. We've spent some time on that. And how do you see AI augmentation and maybe namely deep learning, because we've seen it's some of the key points can address mission complexity and which benefits and also risks involved. Thank you. You have 5 minutes also.
Thank you. Thank you, Bruno. Thank you all. Military mission systems have some issues and challenges for the future. Military mission systems involve more and more functions, more and more data to be handled by the crew. Aircraft systems are fully connected and digitalized, and they extend a lot of data. And we go toward collaborative combats with a lot of data on the networks. And moreover, we have to act with unmonitoring objects, and this increases complexity to manage the mission by the pilots. So military mission systems have to reduce the complexity to manage the mission by introducing a tactical solution for the crew and advices for the crew, and finally to have virtual assistants for the crew. I think AI has a great value to solve this kind of problem. AI can act at different levels of the military mission system chains. The first stage is relative to perception. We see that we know that machine learning image computing is very interesting, for instance, to extract some features from the data sources. We have a lot of data sources in the aircraft, and I think AI and especially machine learning is very suited to extract these features. On the second level, we have to combine these different features in order to help the pilot. And at this stage, I think symbolic AI, as we seen yesterday, is very interesting to put some sense and semantic on the features to give some advices to the pilots. And finally, at the third stage, we have to define a solution. We have to give solutions for the pilot. And at this stage, I think other AI techniques are very interesting, like operational research or constraint programming. It's an example. So what are the challenges to introduce AI in military aircraft, and especially fighter aircraft, which is very small? The first one is the problematic of system engineering process. Today, the system engineering process is very classical with system requirements, and we have to derive the requirements to component requirements and to define the logical of the component, for instance, the software. But now I think it's very difficult to act the same thing. And I think we have to devise a new way for a system engineering process, especially by introducing partnership or couple between operational customers and engineers. Second one, we have to introduce AI in small fighter aircraft, and we do not have a big computer, supercomputer, or data centers in this kind of aircraft. And we will act with a denied environment, and we do not have always the connectivity. So it's important to have edge computing with AI in the fighter. But we have no great place. We have to ensure electrical power. We have to ensure the conditioning of the computer. So it's important to treat the problem. And after that, a third issue is to test the AI-based function. This kind of function has a great variability, has a great combinatory of inputs, and it's important to test extensively this kind of function. And I think the key word for that is the simulation. We have to enhance the simulation at different level, at the software level and at the system level.
Okay, thank you, and interesting things too. And one of those being, I guess, the fact that usually space-borne and airborne platforms are small, and particularly combat ones. So edge far-edge computing may be a key, and we've seen that sometimes AI requires a lot of processing power. Of course, different from training and then inferring, which may be different. Okay, we are in the defense world, so we have weapon and ammunition now after having seen the platforms. And so welcome, Yonatan. You are responsible for digital strategy, products and services, and previously for coordinating artificial intelligence activities for the MBDA group. One can assume that smart munitions and weapon system are logical candidates to AI, for AI augmentation at least, but with, of course, trust and trustworthy as key factor. Could you illustrate, for example, your perception of added value of AI, risk and difficulties? Thank you. 5 minutes.
Thank you. Yes, my talk will be pretty much in line with Stéphane has just said, with a very concrete example of how we can make best use of AI in the weapon system context. I have had the chance to scan a very large number of use cases in MBDA group, and I can retain one that is pretty much in line with air domain. It is about advising the weapon operator performance in the cockpit. I think we think and we have had this very specific application on how to make best use of the performance of a weapon in a platform. So in MBDA, we run a very large number of simulations, both low fidelity and high fidelity data points. And we make best use of this million of data points to infer the performance in real time of the missile. Meaning that as soon as you can do that, you are effectively compressing a simulation, a very robust simulation. And once you can run in real time this neural network, and in a tiny one, because you have a very harsh swap constraint, as just said by Stéphane, you can effectively enhance the weapon performance. So to push the limit of the performance and even to advise the best launch point to make best use of the performance. So with the same missile, you can achieve more performance because in real time, you know when and where to launch. And effectively, you can push the limits of the performance of the weapon. I think it's a very concrete AI application, and it makes best use of the simulation, the IFD simulation, effectively the one that we master in MBDA, and the data that we have already, because it makes best use of this data. The second use case, I think, is as well pretty much in line with what we have just said in this panel. It is about multi-effector replanning in real time. Yes, over the last 12 months in the MBDA group, we have launched what we call the Orchestrike. It's effectively a software that could be applicated with various type of effector to effectively replan in real time the mission, given a number of constraints, linear areas, and even constraints that can come in real time from the sensor of the various effectors, meaning computer vision or electromagnetic sensors. And with these inputs, we can replan and effectively increase the performance of the mission. And I think, yes, you are talking about trust. Trust, I see two factors for trust. The number one is yes, the operator. It is about a decision aid. So the operator has to really understand what can this function can bring and how to use it. But the fire will be at the end of the operator, the human. I think it's number one. And number two is the trust of the engineers on these techniques. Because neural network can effectively be very hard to understand. their capability to effectively compress this information gives us some disadvantages. But we have exploited a number of range of techniques because machine learning is a very large spectrum of techniques. And effectively, for the first use case that I was mentioning, there is two candidates for the weapon performance use cases. First one is slightly lower performance, but more explainability. That's the one we have chosen in MBDA to apply, and that's because we have both the trust of the operator and the trust of the engineers to place it in the weapon performance context.
Okay, thank you all for trying to maintain timing and pretty successful in that without AI indication, by the way. Now, just we have about 15 minutes left. Okay, and we'll try to see two ways and bring in debate, I guess, because of course there may be different positions. We have some questions that popped up. Feel free to scan the QR code to ask more if try to address them. First of all, does any one of you want to react on what anyone else has said? You always share what has been said. Please feel free. Go ahead. Jean-Luc, you have another.
Yeah, just a little question for Yonatan about trust. If I understand, you said for the operator, trust.
Close to the mic, please.
Yeah, it's okay now?
Remote people.
Trust for the operator, he has to understand the decision, okay? Perhaps we can have some examples for which no time to understand the decision because the time loop is very hard. So how can we find another way to gain the trust of the operator if in certain case cannot understand? There are two options presented in front, 2, 3, or one decision has just to say yes or no, or with his own commander intent, he can choose 1 or 2 options, but he cannot understand what is built in front of him. So to gain the trust and in another way, is there an option, for example, to, because in our fighter former pilot instruction, we use, and perhaps tomorrow it won't be possible to learn the aircraft from A to Z. We must by heart know everything. Tomorrow it will be possible. But for instance, if we propose in the formation to the operators or the fighter pilot that okay, you will have decision, you will have an AI or an algorithm, a trained algorithm inside your aircraft, which will propose you some decision. Okay, you won't know the decision, but at one time you will learn how the algorithm is learning, how the algorithm is training, and we guarantee you that the data or the fuel that is used is certified. Do you think that this is enough to gain trust for operators and perhaps for engineers also?
Yes, if I may complete. Okay, how do you train people to use AI and build trust to AI?
So I think like any software product and in this critical domain, you need to co-design the function. And effectively, training is session. I was speaking about very high fidelity simulations. I think the first thing to do is to put the operator, the pilot, and this function, this AI function, in the simulator first place. Before even to think about, fine-tuning the function. So first prototype, first step is to prototype with the pilot. And effectively, the question will be, the response will be, no, we can't use it like this. And I think it's a very good point. But first thing in this critical domain, you need to not even to train, to simulate the use of this AI function.
Other reactions?
Maybe if I may just add something, the fact that anyway, in the end, when we will be talking about decision making, it's about a full information processing chain. And on the industrial part, we don't know really what it takes. So in the end, it will be, of course, a common action with end users to co-learn what will be the best results to achieve. So understanding the domain, in the end, we are talking about data, and data is exactly the essence of the domain. So it's not possible to generalize everything. So there are some principles, but in the end, representing the knowledge and going into the final details will need time and will need intimacy between the machine, the users. So it's about learning and co-learning. So I would say in the end, there will be a need to define all the necessary simulations, environments to make that happen really.
Yes, Pooja?
I have a short point to add there. I think a lot of it will be attributed to the time aspect of it. I mean, a fighter pilot will not see a new AI algorithm for the first time when he is in an operational scenario. So he will have seen it before, he will have interacted with it before, he will have undergone the training and the necessary know-how in order to operate that. And it can be from both the sides. One, from the digital aspect, as in what information is being shown. Is this the right way to show the information? Can the pilot make sense of the information that is shown? Are the right parts highlighted? Are the unwanted parts not highlighted? All of these aspects, plus the human factors aspects of it, as in, is there a button that he needs to press, and is the button placed in the right position? Should it be somewhere else because ergonomics is acting here? So all of this will be done before. So what we see in the operational scenario is very much the tip of the iceberg, I would say. And there is a lot of work in the background that needs to happen for the operational scenario that we're all talking about to come to fruition. So this is my point there. Okay, so interesting to see that the principle sell and forget should be disregarded completely, all the more now with AI, if I get it right. Maybe Ed, we don't see you, but maybe you can listen to you if you're still there.
Yep, still here. Yeah, I think a lot of that discussion has been around kind of onboard AI or AI that the operator, whether that's a pilot or someone in a C2 headquarters is kind of interacting with. I think it's also important to recognize the kind of offboard AI that will be involved, which kind of goes to Pooja's point slightly. So if AI has been heavily involved in the C2 headquarters, planning, but what arrives in cockpit is just another message over a data link. Some of this, the operators will have no idea where AI has been involved. So that's more that kind of trust of the system. So just the trust from everyone using it that where AI has been, involved, there's that collective trust, because how the pilot, the operator is interacting with it might be no different to how they're doing it today. It's just it's how that information has been, orchestrated that has changed. So I think that's an important factor, as well as the obvious kind of bits of AI that are in cockpit and the operators know AI.
Yeah, interesting point of view. So that actually you should be able to forget that AI has been involved. How far is it possible? And I just step on another question that raised up when talking about defense matters, because we alluded to the devastating effects of getting the wrong answer to a question that AI have for any reason. And we've seen many of those turning a lorry into an ostrich that can have dramatic effects. How different should be or are or will be AI algorithm, to make it simple, from civilian world to defense world? Can it be the same? You are from companies that are, although you addressing, except MBDA maybe, civilian and military applications. Are those different? And I think Jean-Luc mentioned one important point. You don't have so much time to to answer and to analyze, to understand and answer, because the enemy will be faster than you. So how do you see this difference developing, if any? Stéphane?
AI technology is the same for the both domain. But I think, as we have seen yesterday, for ESA, for instance, the purpose is for 2025. We have the functions at the level of DALD. It's not very high, and so I don't think that the military domain have the time to stay here, and so regulations are for good guys. I think for military domain, perhaps it's not the case, and I think a military domain is a domain which push very strongly the domain of AI, because the risk is not the same. I think.
Pooja?
Yes, I want to add a few points there. Interesting perspective from Stéphane. A lot of what was discussed yesterday involves a very specific definition around the MLDL framework. And this defines the assurance process that needs to be followed when developing an algorithm, which is data-driven. And I think this is a set of best practices that are being put together, and they could be followed cross-industry. And they are applicable within the civil domain. They are as much as applicable within the defense domain. So, I think the borrowing of these principles into the defense world to develop algorithms makes full sense. So there at that level, I don't see any difference. But sure, the operational aspect of it, as in the not having the time to react aspect of it is very present in the defense domain. And like Stéphane mentioned, the defense world will not wait for the civil to push the different criticality application levels. So the research and developments will be led here, but I think it's the same across the two domains of how you design and develop the algorithm, and how do you verify and validate them. Maybe the end performance metrics will be different. For instance, not at the algorithmic level, they are still the same. They are precision, recall, F1 score when you do a classification, that's it. But then when you think of what's the final KPI that you're achieving, maybe you will say safety in one domain, maybe you will say mission success rate in another domain, but that's where we will differ. But in the basic methodology of development of an algorithm, I don't think we should differ, be it civil or defense or space domain. This is my perspective on it.
Okay, so maybe we have time for a last question. We'll have just 5 minutes left to get your coffee after. The point that was mentioned, and I just take on the question of how do you evaluate the risks of having those advice as being wrong? Is there a possibility for the AI to self-declare that, okay, I may be wrong at whatever level, I don't know, because particularly in the consequences, Mike Hensley for the situational awareness definition, they put the collection, the perception, comprehension, and projection. So what are the consequences of this essay for me if I take such or such actions? Does AI has a possibility to illustrate for you, the operator, being in the air or on the ground or in space, the consequences of the choice?
Consequences of choice.
So maybe it's a silly question, but I know that. Just so you save time for coffee, but
so maybe
Christophe or Ed maybe.
Yeah, simply there's no silly question in that domain. I agree with that completely. And AI in itself is a full new domain, and it's still moving a lot. So there are only good questions. And
thank you.
So yeah, on that side, I think for that question, that maybe two things. First, I know that there are a lot of studies about trying to understand uncertainty as or accuracy of a model. It depends the way you say it. So there are a lot of research on that with the goal to provide in the end for a decision a level of confidence or something like this. So probably at the time, I think it's still a research domain, but it's ongoing. And the second part of the question could be maybe more, I would say, procedural or embedded into the decision loop, which could be to evaluate courses of actions according to possible decisions and simply try assumptions and see the results. Then maybe doing so, the failure or the bad proposal could give or raise and be more visible and be then corrected. And by the way, that's the role of the user and user to arbitrate in the end.
Okay.
I can come in very quickly if you want.
Yeah, go ahead.
So I think kind of goes back to one of my similar points about we need to apply the same level of scrutiny that we do to humans in some of these cases. So I think there are a lot of decisions taken by humans, in an operational setting that are based on their decades of experience and the collective experience of their teams. And they're explainable enough, and so I think that's part of it. We don't need to over explain. I think the other factor I think is it's about the level of risk. Okay, so I think if you're making a decision that would save lives rather than take them, then maybe you would have a lower threshold for how much AI autonomy you would allow. So maybe in predictive maintenance, okay, would you actually rather have a lower threshold for what triggers a component change, because that should be safer, although you could probably debate around that, versus if it's more in the kill chain, then there are far more checks and balances, just as we have today, and you're just kind of swapping out little bits of human interaction for AI interaction. So I think it's very much a sliding scale, and I think risk is an important factor in that.
Interesting. Thank you, Ed. And Pooja, maybe last word.
I will be very short on this, but a very important point I want to highlight is that what is AI doing here? AI is an assistive system. The responsibility of action and the responsibility of defining the action, what needs to be done, stays with the operator. Right? And AI is not like, if you are using AI for planning and scheduling, let's say, it will not plan and just show the plan and say, please go ahead, without having any future guarantees. This is acting in a loop. So it's giving you some information, giving through the operator an information, giving the different options. Based on the options chosen, it is again giving the next possible options. And it's doing it all the way until a goal has been reached. And this goal has been defined by the operator. So this is how AI can prepare a future guarantee, like about the future guarantee that you are asking, Bruno. So that's my 2 cents there.
Okay, I just maybe no conclusion or just one. Seen yesterday is, okay, AI is different. I think we have to abide by that. And I will just leave you there. 2 more panels to go and 2 roundtables. You have occasions to develop that. And thank you all. Thank you, Ed, and thank you to the remote audience and in the room. Have coffee.